All right, so in section 5, we're talking about different counting techniques. Multiplication U, permutations, multiplication rule, permutations, combinations, non-distinct items, and involving permutations and combinations. So let's look at a couple of these and maybe some of the formulas that go along with them. Again, I'm going to suggest that we use technology to push us along with these. We'll get back to those. So calculating a combination. And so a combination is finding the number of arrangements of something. So with permutations, the order is important. With combinations, the order is not. So if, let's look at a scenario, and this will help it make sense. If there was a fire in the building we were in, and there's 20 people in the room, the first 3 people who got out are safe. The order is not important of those 3 people, right? It's just that they're all 3 safe. So that would be an order of an idea of a combination where the order is not important. If the first 3 people got out, but the first person is unscathed, the second person evacuating the room got a broken arm, and the third person, half of their body, like if it was a fire, half of their body was burned. They still all got out, but the order that they got out is important. And so that would be an example of a permutation. So that's a little extreme, but it kind of gives an idea of when order is important, when order is not important. So combination, the order is not important. So on our technology, there's different ways to do combinations. On a TI, there's a permutations and combinations button. There also is a factorial. This is something else used to calculate these. And is an operation that we do in math. For example, if I want to know what 5 factorial is, 5 factorial means 5 times 4 times 3 times 2 times 1. And so it's just a countdown, which is 120. These get large really quickly, faster than exponential things, potentially, or always. Potentially or always, one of those. But these operation, this factorial, is used when calculating a permutation and combination. And they talk about more of that in the text. But if I wanted to figure out this, 9 combination 8, I would do 9 combination 8. And it'll tell me there's 9 ways to do that. Like if I have 9 people, and I'm picking 8 of them, and the order does not matter, there's 9 different ways of doing that. Let's look at a permutation of this. If I have 9 people, and I'm picking 8 of them, but the order is important. Let's say they won prizes. The first person won $1 million. The next person gets $500,000, then $300,000. And so the order is important that you're picking these 8. There are a lot of different ways that we could arrange these 8 people that we're picking. So in a permutation, you're going to have more ways of doing something with the same values. Another one to look at is number 8. So in number 8, suppose 34 cars start a race, and how many ways can the top 3 cars finish the race? So is the order important in a car race, or is the order not important for that top 3? And so that's something that you have to decide. If it is important, you're doing a permutation. If it is not important, you're doing a combination. And then you just do 34 permutation or combination 3. So if the top 3 qualify versus the top 3 finish, and you have places, so think about that. And lastly, I want to look at number 12. It's looking at distinct items. So a golf course architect has 6 trees, 3 white birch, and 2 bald cypress trees to plant in a row along a fairway. And how many ways can the landscaper plant the trees in a row, assuming that the trees are evenly spaced? So this is one we're looking at permutations with distinct or non-distinct items. So I have a total of 6, 3, and 2, so I have 11 trees. So here's the formula that's in your text. So it's taking all 11 trees, and we're going to divide by the multiplicity of each tree. So we have 6 factorial times 3 factorial times 2 factorial. So this would be the process. You take the total amount that you have and you divide by the product of all the multiplicities of them. And so in this one I get 4620. So these are the distinct ways that I can maneuver these trees along the fairway. But it's using the formula for distinct permutations. I said non-distinct earlier. Distinct permutations.